As of the year 2013, the 4L60E has been in production for over 21 years, and I want to spend a few minutes to help you recognize the changes in its design over time. I also want to show you how to locate and decode information on the case so you can learn at a glance things like the year it was made and which engine it was paired to. And finally, I want to talk about compatibility issues with torque converters, filters, and dipsticks. I want to start by dividing the 4L60E into three groups based on how the case changed over the years. The transmissions I have here are for production years 1997, 1999, and 2004, and they're perfect examples I'll use to show how the 4L60E evolved over time. The first group, built from 93 to 1997, has a one-piece case. The next group, manufactured until 1999, introduced the two-piece case and bell housing arrangement, a stronger extension housing, and a deeper fluid pan. And the last group, introduced in 2000, has a deeper bell housing to accommodate the longer 300 millimeter input shaft and a larger torque converter. Of course, there are more but less obvious differences, so let's take a closer look at each group. Okay, this is an example of the 4L60E design manufactured from 1993 through 1997. It's easy to identify because the case and the bell housing were cast as one piece. All 4L60Es have a bolt-on area on the rear. Whether or not an extension housing or transfer case adapter is used, 4 bolts attach it. Depending on what year, there are 2 types of vehicle speed sensors in 2 different locations. From 1996 up, a type like this is located on the passenger side. A larger, approximately 2-inch diameter type was used in this area from 1993 until 1995, and the Corvette continued to have it here through 1996. The information sticker is always located in this area, and it's very important. If it's missing, or as you can see in this case, you can't read all the characters, the ID information is stamped in the case on the passenger side at the rear, just above the pan rail. I'm going to talk more about deciphering this information later. All 4L60Es have a large 12-pin case connector in this area on the passenger side. They can be purple or green in color. The harness end looks like this. Here you can see it has the historic 1955 and up 6-bolt engine pattern and the angled dust cover arrangement like the Turbo 350, 400, and Power Glide. Always look closely at the flanges. 4 holes meant it had a plastic or thin sheet metal cover attached with 10mm headed screws. 6 larger holes, 3 on each side, indicates a 4-wheel drive model which used a much thicker aluminum cover with 15mm headed bolts. 1993 and 1994 are wired only using a TCC solenoid for simple on and off control. The torque converters for these years use a paper-based clutch lining and should not be interchanged with later transmissions. 1995 and up have an additional PWM or pulse width modulation solenoid and a different wiring harness to gradually control the lockup clutch in the torque converter. The correct torque converter for these years have a Kevlar or woven carbon lining material to handle the extreme heat generated by the intentional slippage of the clutch. Although you should always go by the information on the case, here's a little visual clue to look for. 1995 and up transmissions have PWM cast into the pump cover. One last characteristic I want to point out is pan depth. The 93 to 97 years typically use the shallower pan like the one shown here. Later versions get a deeper design, as you're about to see. The next group, made from 1996 until 1999, centers around a very radical change for the 4L60E, the two-piece case. Even though GM continued to produce the one-piece case version through 1997, this newer removable bell housing type was actually first introduced behind the 4.3-liter engine in 1996. There are many different bell housings cast for this transmission, but there are only three you need to be concerned about if you live in North America. They are the 90-degree V6 and V8, like this example here, the 60-degree V6 version that bolts to 3.4 and 2.2-liter engines, and an adapter used only on the Corvette. All bell housings are fastened to the case with 8 bolts, and only a Torx Plus bit should be used to remove them. Notice here that the traditional 1955 up bolt pattern is still used, but the bolt area continues all the way around with 3 new bolt holes. 9 bolts now attach the transmission to the engine. The 298mm torque converter and input shaft from the 1993 through 1997 version is carried over to this group, but now with only a Kevlar or carbon clutch lining. I'll talk about torque converters in more detail later. The information tag was moved to this area of the case. As you can see, this one's missing, so we have one from another transmission just to show you what it should look like. The 1996 through 1999 case connector is of the same type and in the same location as earlier units. The extension housing or transfer case adapter is now attached using a stronger 6-bolt arrangement. The vehicle speed sensor remains located in the same passenger side position. Fluid reservoir capacity was increased with a stepped, deeper sump pan. Our last group, the 2000 and up version, continues to use the two-piece case and bell housing arrangement, but with significant upgrades. First of all, the bell area on the 90-degree V6 and V8 housing was lengthened for a larger 300mm torque converter. This increased the length of two-wheel drive and four-wheel drive transmissions by 3/4 of an inch. This housing on our 2004 example adapts the transmission to a transfer case used on four-wheel drive vehicles. Notice it has the same 6-bolt attachment pattern as the previous 1996 through 1999 years. The case connector is still located here and should be green until 2005. The color is black from the year 2006 and up to denote an internal wiring harness change for an additional input shaft speed sensor. The 90-degree V6 V8 case to engine bolt pattern changed again, but still incorporates the classic 1955 up pattern. A hole was added at the very top. There are now only 2 but repositioned bolt holes in the lower area. As I mentioned before, the 90-degree V6 V8 bell housing is now about 3/4 of an inch deeper. This change was made for a larger and stronger 300mm torque converter. The input shaft is now slightly longer with the splines in front of a much larger TCC O-ring. The converter clutch lining is now woven carbon to endure the heat generated by the long-duration partial apply strategy of the PCM. The 60-degree V6 and 4-cylinder bell housing, converter, and input shaft are the same as previous years. A heavier duty version of the 4L60E, the 4L65E, was introduced in 2001. It has additional planetary pinion gears and a higher clutch capacity for the 6-liter engine. All right, if you're still watching, you may be a little confused about this transmission and its variations over the years, so I want to spend a little time on identification. My best advice is to learn to read the information on the case. I have to admit, even though I've worked around these transmissions for years and can recognize physical differences, most of the time I still go by this, the tag. The tag tells you what year, which engine, transmission type, manufacturer location, and serial number. And remember, even if the sticker is missing, all 4L60Es have information stamped or engraved into the case. If it's missing on a 1996 and up 2-piece case, the characters you're looking for are engraved on the bottom in front of the extension housing. As you can see, the characters are the same. Remember, if you can't read it or the tag is missing on the 1993 to 97 transmission, the info is stamped into the case on the passenger side above the pan rail. Let's decode the characters from this tag on this 2-piece case transmission. The first character denotes production year. The 4 could mean 1994 or 2004, but because this is a 2-piece case, logic tells you it's from the year 2004. The next 2 characters indicate the engine it was paired to. From information easily found on the internet, KC indicates a 5.3-liter engine was used in the vehicle. The 4th character tells you what transmission model you have. D always means 4L60E. Notice how the large characters are repeated in the longer series down here. The next letter after D indicates manufacturing plant. Y actually means Toledo, Ohio. The next numerals make up the serial number. There's a lot more info on decoding transmission tags on the internet. Let's move along to 4L60E torque converters. What we're looking for is on the other side. Like the tags on the transmission case, tags on GM torque converters tell us a lot. The first character indicates application, such as engine size. In this case, 6 and 5.3-liter engines. The second denotes stall information. M means low stall. The third character tells us clutch damper type and lining material. B is for woven carbon. The fourth is the cover type, as you see here. Most torque converter remanufacturers need this code to correctly replace it. There are 3 different filter types depending on the year and depth of the transmission pan. The types are shallow, deep, and Corvette. And always remember this rule. The pan determines the filter type. Let me show you. The 1993 to 1997 transmissions and some 1998s came with a shallow pan and used this style filter. As you can see, when measured flat on the table, the tube is about 4 inches high. The 1998 and up transmissions came with a deeper step sump area in the pan and use this style filter. And even though it has the same footprint as the other filter, as you can see, the tube is about a ½ inch taller. This one is 4½ inches tall. There is a third style filter used on Corvettes I want to mention. I don't have an actual example to demonstrate, but the filter looks a lot like the shallow pan style except for an added standpipe in this area. It's used with a unique pan with a sump in the middle for this high performance car. Here we have our 1997 transmission with a shallow pan and a 1999 transmission with a deep pan. Notice the filter depth as I remove each pan. As you can see, there is a big difference. Using the wrong filter can cause problems. Obviously, attempting to put a shallow style pan with a deep filter is not going to work. Using a deep pan on a shallow style filter can also be a disaster. The filter could fall down in the pan and come out of the seal in the pump. It could draw air and starve for fluid. Always remember this rule. The pan depth determines which filter you use. Shallow pans go with a shallow filter. Deeper pans that have this step use the deeper style filter. Using the right filter can be confusing, so I hope this helps. Dipsticks can kill. Yep, I've seen it happen. Dipsticks and tubes are calibrated together, and sometimes they get mismatched and can cause bad problems, like incorrect fluid readings, which leads to low fluid level and eventual transmission failure. Let's take a closer look. Here's a great tip to keep in mind when working with not only the 4L60E, but also other transmissions like the 700R4, 350, 400, and even the Power Glide. The correct hot and running fluid level is at the pan rail. And you want the full mark on the stick to indicate this. Remember, the rotating parts are always above this area in an automatic transmission, never submerged down in the fluid. To calibrate the tube assembly you want to use, hold it beside the case as it would be if installed. Use tape and mark the pan rail line as you see here. Now slide the stick into the tube and note how far the end protrudes. Now remove the stick and see if the hot full line corresponds to the mark you made. You might have to get another stick, tube, or both if it's more than 1/4 inch off. You could resort to simply calibrating it yourself by scoring a new full mark. One more point about dipstick tubes. The length, bends in the tubing, and attaching bracket vary depending on case type. Notice how the assembly for the 1999 model year does not fit the 2004 because of the longer bell housing. To finish up, I want to say the 4L60E changed a lot over the years, and while I didn't have examples to cover everything, I hope this information on what to look for on the outside has helped. My best advice, Learn to read the tag, especially the first 4 characters. Good luck with your 4L60E.